big shout out to the organizers of this conference because this is great, right? Like everybody's having a good time. Lunch was awesome. Like this is a lot of hard work and it's really hard to pull off. So like major props to the organizers. So little like poll of the audience, like who knows Taylor Swift? Okay, yeah, you laugh. I've spoken Switzerland, and I was really like delicate about figuring out what people knew and didn't know. All right, and like we know she has a few like commitment issues, or maybe previously did. I think she's turned over like a new leaf, but there's going to be some references and to all of that in here. But today I'm going to present a bit of a love story about serverless architecture. And really, I certainly have a love affair with serverless architecture. I've been speaking about it for like maybe a little over 2 years, like not too long after Lambda was a bit in prime time. And I really enjoy it. And I love speaking about it. I've given this talk once before, which was in Switzerland, and now this is my second time. And I've had to kind of update it a little bit because if anybody's kind of working with serverless architecture, it's changing constantly. Every time there's a Google Next or a reInvent, then I'm like, oh man, I have to go update all these slide decks that I might want to deliver this year and go figure out what the latest and greatest is. And things are moving quickly, but it's fun. So as the intro said, this is me. I'm at Lina Lu on Twitter, on LinkedIn, on GitHub, everywhere on the internet. For any sort of questions or connections, probably Twitter or LinkedIn is the best way to get a hold of me. But yeah, feel free to reach out if you have any questions about really anything, and I'm happy to chat. This photo is me flying a mini quadcopter in Rome. And it did eventually get stuck in an olive tree, and we couldn't get it down. And I work at Microsoft. But when I wrote this talk, I didn't work at Microsoft. So there are a lot of opinions in the talk, and I'm going to give a lot of opinions that are really mine. And like I think my team supports me on that, but maybe, like my opinions are not Satya's opinions. So, don't go on Twitter and say like, did you hear Bill Gates hates Kubernetes? No. I don't love Kubernetes. That's a whole nother story. But I love it. I just don't ever want to use it, which is why I'm using, when I'm talking about serverless. But yeah, my opinions are my own, yada, yada, disclaimer. So I run a lot of meetups and things in the Norfolk, Virginia community. Revolution Conf is a conference that I help organize in June. It's on the beach. If anyone's interested in attending sort of a technology agnostic conference, feet from the ocean, check it out, revolutionconf.com. This Ninja Cat here is the Norfolk JS Ninja Cat. I've been running that JavaScript group for about 6 or 7 years now, and we have a huge NodeBots Day event every summer, about 300 people, tons of kids, fun times. But enough about me. We're going to talk about serverless architecture and why we're going to fall in love. But before we can fall in love with serverless architecture, we have to end things with our servers. And not servers in general, because we all know serverless really does have servers. Like, don't put that in the Q&A. It really does. They do. There are servers. We just call it that, blah, blah, blah. But you have to break up with you configuring servers and you worrying about servers. And when you're creating an architecture and when you're designing software, you should never be worrying about the infrastructure behind it. You should be focusing on your app and on your code. And so we're just going to break up with that idea. So the story that I'm going to tell today has all the pieces of this ideal romance or a typical romance. We just talked about the breakup. We're going to talk about decoupling in relation to microservices. We're talking about commitment to tools, commitment to cloud platforms, maybe not committing to anything. I'm going to talk about developers, how we have a little bit of commitment phobia when it comes to basically everything. Highly cohesive relationships, if you're into that, we'll talk about it. You can get it here with serverless architecture. High availability and dedication. When you're talking about basically anything hosted in the cloud, then it's going to be highly available, and that's really nice. The server we just broke up with, that was sort of a bit of baggage in that relationship. And support and growth. So we're talking about scalability there too. I was watching a video from, I think it was like a previous Microsoft event, and Scott Hanselman was talking about how, he has like a 5-page resume, and page 2 was entirely about like scalability and reliability. And like now, with like the cloud, any cloud, like we just don't worry about it anymore. We can just delete that page of the resume. So a lot of the things that were a primary part of our job in the past, we don't worry about day to day. There's a whole team of people at Amazon, Microsoft, IBM, Google, like worrying about that for us. So every serverless talk, serverless is now becoming a bit more of like a household name when it comes to tech teams, but every slide deck like still has to have this what is serverless architecture. Like we still have to say yes, there are servers. And we have to give a definition, and they're usually different. If you look at talks I gave a year ago, the definition is different than it is today. But really, it's a totally made-up term. It's a bit like cloud was a couple years ago. The joke was, oh, the cloud is really that server under your desk. Like, ha, ha, ha. Okay, serverless. Oh, there's really servers. Yeah, it's a catchy marketing term, and it's fun, and, we'll go with it. But really, I think, did I miss? I feel like I missed a slide. Well, I'll just talk about it. I think I accidentally deleted a slide when I was messing earlier, but with my actual definition. But my definition of serverless is really to focus on it being an event-driven system, and it using remote services. And those remote services are usually a functions as a service, like Lambda, like Azure Functions, like IBM Cloud Functions. And now that's getting a little bit fuzzy, especially in the Google arena where you have serverless containers and you have is App Engine serverless? What about Athena, which is sort of a serverless database? And, so there's a lot of these kind of iffy situations where maybe you could design a serverless architecture without a functions as a service tool, but generally it's in there somewhere and it's the backbone. And really this idea of serverless architecture, as we're talking about it today, kind of started with Lambda. And people still, when they say, oh, serverless, that's Lambda. And it makes sense. But ultimately, my definition and what I'm going to talk about, even though I'm saying that Lambda or Azure Functions might be the backbone of an architecture, it's really all about the events. And for us old folks, that's just event-driven architecture, and we've known about that forever. But now we're bringing it back, and we're bringing it into this new cloud ecosystem where it's a fully managed event-driven system. And now we have all of these managed services across our cloud, and we're communicating back and forth using events. And it helps us create this really decoupled system, but we're not managing the pieces. So yeah, as I said, it's all about the events. I'll just pause and let you guys just enjoy this slide, which is just everything 80s and today about fun time events. But yeah, this is a really important part of serverless that I feel like gets glossed over a lot because we're really concerned about the execution of it. But it's really powerful that you put something in storage, and just that action of putting something in storage generates an event, which then triggers a function, or or maybe it triggers something else, which then becomes part of this bigger architecture. And it's really interesting. Oh, here it is. I found it. So here's my definition that I basically already talked about. But the other important thing here too is that we don't care where our code gets executed. If our code is in this function as a service, if our code is in this Lambda or Azure function or whatever, we don't care about it. We don't care about that container it's running in. Maybe we care about the runtime to some extent, which we have a little bit more control over, but yeah, we don't do any management, we don't do any orchestration of these execution environments. And I'm saying container here, but execution environment is sort of a better term because Amazon doesn't really classify their environment as a container exactly. So now I'm going to talk about FaaS for a little bit, functions as a service. Another little side note tidbit, when I was in Switzerland, they love the Fresh Prince of Bel-Air. I watched many dubbed episodes of Fresh Prince on television, like late night before I presented there. So I put some little tidbits of it into my slides here, and then I kept them because I just love this. But as I said, these are stateless functions. It's code running in an execution environment. It's not yours. You can have varying levels of control over this environment, just depending on what you want to do. For me, I like to not think about it at all. I like it to be as abstracted away as possible. And it just depends on the cloud provider and the tools as to like how much control you have or you don't have. But as I said before, I really feel like FaaS is kind of the heart of serverless architecture. Every system that you're designing, or at least most systems, there's going to be a function in there somewhere. It's a great connector. It's a great kind of flexible piece. I mean, even if you're using services that are serverless kind of on their own, or like in Azure, we have Logic Apps, which is sort of I call it like a plug and play or like a drag and drop kind of interface. But I still use functions with it a lot because I still sometimes need something else to happen or some connection to happen there, even though I already have this workflow tool. Same thing with like AWS step functions that are really powerful, but you're still going to kind of have functions in there. So it's kind of like sort of the glue, it's kind of the connector, and this idea of FaaS is the heart of things, and it's kind of where it all started as far as serverless in the cloud. My little Twitter logo, I guess, jumped a little bit on this one. That's what you get for tweaking slides right before a presentation. Like, you just need to do it the night before and then leave it alone. Stop like moving stuff around. Is this centered? Just leave it alone. Okay, so just continue to talk about FaaS a little bit. So yeah, fully managed. They're stateless. Every time a new one spins up, it's completely new. It doesn't remember what happened last time. You'll hear people talk about cold starts a little bit. I feel like cold starts aren't a thing. I mean, they're a thing for Amazon internal. They're a thing for like these systems that have to be highly performant. But for the average person, we're talking about milliseconds here. And most of the time, if you have a function that you're hitting like quite often, it doesn't even have time to shut down before you hit it again. So you may actually hit the same container. And the cloud platforms are sort of working around different ways to sort of even get around cold starts too, if it's really an issue for you. But I think it's overhyped. I think that here comes like, this is just me on the soapbox right now. I think that people need a way to sort of criticize things or have a reason like, well, what about the cold starts? It's not an issue. Yeah, it's the time it takes the container, the execution environment to spin back up. But it's like, it's so not to worry about. It's the same thing with languages. I've done talks before where I've compared like which languages are more performant, which runtimes are more performant. They're all the same. Like Java's faster here, and it's like nanoseconds faster than .NET or something. But what if you use a language that you're not familiar with or that you don't like, just because it's nanoseconds more performant, or that your team isn't on board with, just for some weird performance tweak? Don't do that. That's dumb. So anyway, I'll step back off my soapbox. But yeah, no worries about infrastructure here. I respect the container ecosystem. Absolutely. I don't want to touch it. I don't want to worry about it. I want other people to make it good. You don't want me orchestrating anything. I can do Kubernetes, but it's like, I'm just like, whew, man, I just had to orchestrate some containers. Like, I'm just like complaining the whole time. Just let me write code. Somebody else who loves it, do it. So I don't have to worry about infrastructure here. The other thing too is that, if you're creating a POC, if you're creating something for a client, you're just trying to get some app out the door, and you're not, a wizard in containers, then that can be just like this clunky, worrisome part of creating the application that you don't need. And so this just helps you get off the ground a lot faster. And one really important note is that serverless is really inexpensive. As you start to branch out to other cloud services, that's when you start to get into money. Databases are expensive for sure, and other sorts of queuing systems can start to like cha-ching, but fast, they're always cheap. I mean, a lot of times you're not paying for them until you are paying for them, and then it's just pennies. So you could design applications that are essentially free. They're so cheap. When you're used to the olden days of, I'm hosting my WordPress blog, and you just pay for that blog to exist somewhere. Like, you don't even know if anyone's hitting it. Maybe you have times where people are hitting your blog a lot. You've got a really hot blog post, and it's super busy for a month, and then nobody touches it for 9 months because you're really busy and you're not blogging. That doesn't happen with FAS. With FAS, you're only paying when someone's hitting a function and that function's actively being used. And if it's not being used at all, you don't pay anything. So, yeah, I mean that's super powerful, and really that's a huge change when you move to this model of serverless. A couple sort of, I guess, anecdotes about that. Early on in my talks, when I was first sort of introducing serverless, I talked about Netflix. I don't know where Netflix is now, but when they were one of the first users of Lambda, and they were one of the first companies to really start creating these big APIs, and they converted over thousands of APIs. And they actually were like calling Amazon and checking their bill because they didn't pay anything for like months, even though obviously their APIs are really busy, because it's just so cheap. I mean, you can hit it 1 million times before you start paying for it. So the APIs that were less popular were basically free, and maybe pennies for the more active ones. The other good use case is A Cloud Guru. I don't know if people are familiar with A Cloud Guru. They're a training platform. They're great. And A Cloud Guru, I think, is the first real site that came up as a startup that's completely serverless. So that entire platform was built on Lambda before Lambda was like really ready for prime time. Like, they were really building it in a back room and it was in beta. And they spoke at Serverless Conf. Sam, one of the brothers, who I think is maybe the CTO of A Cloud Guru, I don't know. But he did a talk where he talked about their monthly bill being like under $50. I mean, that's kind of insane. So yeah, that's another good use case. If you want to talk, like, kind of get down into cost and look at how you can architect an entire system from the ground up, serverless, and how cost effective it is, that's a good use case. So now I'm going to go through kind of like the more popular fast services by cloud platform. I'm trying to keep this talk a little bit more agnostic. I know this is a little bit more of an AWS heavy audience, but there's good things and really interesting things on every platform. And so a lot of my talks are pretty agnostic because even though I work for Microsoft, I probably now know Azure the best. I'm still really interested in what everyone's doing and their reasons why. So I'm going to go through. This is pretty opinionated. These are the parts that I always end up having to update a lot. But first is AWS Lambda, which I call the most popular kid in school. And that's because they are the most popular kid in school. I mean, they're like by far, as far as serverless, I mean, Lambda's more of a household name than even serverless architecture, certainly more than Azure Functions, which is probably next, and then maybe like OpenWhisk after that. And Google's doing some interesting stuff, which we'll talk about in a minute. But yeah, I mean, Lambda is extremely performant. Because they were first, they're sort of jumping way ahead. Every reInvent, there's just some really interesting things that are coming out. And they're probably also the most closed. So there isn't really the type of open source development here that you would see with Microsoft or IBM. But there's definitely some really cool technology coming out. And yeah, so I mean, they're first in the market. They're really trusted for that reason, and they have a real focus on enterprise and a real focus on performance. And a lot of that, I think, is because, I mean, they eat their own dog food. Lambda's used internally, and I mean, Amazon knows something about huge retail systems. So having an eye on performance and scalability is really important. And I think I have to give them some props there. The next two came out of reInvent this year, and this was pretty exciting because I was on a panel, I think, right before reInvent, and someone was asking me, well, what do you think is missing from serverless architecture, or what do you think cloud platforms are missing? And I said, even though I don't care about managing containers, I think the ability to create your own runtime and have control over your runtime is important. Because even though I don't want to do that, a lot of people have very good reasons to want to do that. And so that was something that I was that Google was definitely moving towards, that IBM/OpenWhisk has always had. Microsoft has been pretty open about their runtimes. And so the fact that you can now create community runtimes, and they've kind of opened up Firecracker a little bit, that's all really, really interesting and cool. I mean, there's a community runtime for COBOL. I mean, if you want to use Perl, you can now do that on Lambda. So really cool, really interesting. Runtime layers, too, is pretty interesting because sometimes depending on what you're doing in your Lambda, you might be needing to import a bunch of libraries, and that can get kind of clunky, and that can make your Lambda kind of big. And one thing that you always want to do is keep them very, very small and lightweight, because they're just going to be the most performant. So layers just allow you to add different layers of libraries, different layers of functionality on top of the runtime. And it's just like, you're just putting like mayonnaise and mustard and layered cheese on the bread, essentially, like before you start building the rest of your sandwich. And I think that keeps things a little cleaner. I think I've heard complaints about debugging, but there's complaints about everything. I mean, obviously, I don't care. I don't care about most complaints because I feel like they're sort of manufactured. But I think this is cool. But I also think it's new, and there's always just bugs to work out. Step functions is really good. I've seen step functions maybe overused a little bit just because people are like, I need a state machine. But it keeps things organized. Like, you should never be chaining lambdas. So step functions helps you so that you have this state machine. You have some organization there, really. So it's a really good service. And I don't have anything bad to say because this is a love story, and we don't say bad things in love stories. We throw no shade when it's a love story. But I'll probably have more love here because this is where my paycheck is generated, is in Azure. But this slide is the same from even before I worked at Microsoft, which is, and I mean, this is like, haha, Microsoft, no, they're not our favorite. But like, this is where their focus is. If Amazon is a stock trading floor and they just care about, getting the numbers up high and performance and enterprise, then Microsoft spends a lot of time thinking about, well, how do the developers feel about this? Like, can they deploy a function easily? Like, do they like to code on our platform? Does their preferred IDE work with our cloud? I think they put a lot of work into VS Code, which I'll talk about here too, because I have like in a special, like super special love affair with VS Code. This is after many years of hating every single editor that I've tried since I wrote Java and Eclipse. So I really like VS Code. But yeah, I think that Amazon doesn't, I don't want to say they don't care about the developer, it's just not a focus. Like making their dev tools the best ever is not a focus. It really is at Microsoft, because they really feel like if the individual development team is really bought into a tool and a product, then that's going to help get company-wide adoption. They feel like there's a lot of power in development teams. And that makes sense when you think of Microsoft as a software company. So the runtimes are open source, and they run on Docker. Not everything is open sourced, but you can understand how the runtimes are built. And AWS, Lambda definitely has more public runtimes. Microsoft Java just became GA. I think it was in February. So I think Node and .NET came out pretty quick. Java's next. Python is really, really close. I don't know. I don't have any dates on when that's available, but yeah. Let's see. Developer tools and plugins. Yeah, there's great. Like VS Code has great plugins. Visual Studio has great plugins. It's pretty easy to deploy. So that's really important, because you want to be able to show respect to your CI/CD pipeline and your development process, and you want to keep things mostly the same as what you're used to, and then just change where things are deployed. Like the only change from your typical development process, you want it to be just move this idea of cloud development or it hosted in the cloud, but you don't want your day-to-day like typing in a IDE in the deployment. You still want to run your unit tests. You still want to run your static code analysis and that sort of thing. So you want all that pipeline stuff to stay the same. So having really great development tools and plugins helps that. Microsoft cares a lot about offline development too, like making sure that you can do some debugging without, if the internet gets cut off and you don't have access to the cloud, you can still debug offline for a little while. Amazon cares a little bit more about that. I think in reInvent they talked about a little bit more about hybrid cloud, but prior to that it was mainly more of a focus of Microsoft and IBM. Brand new is the Premier tier. If you care about cold starts, and you like the cost effectiveness of serverless, you don't care as much about, but you want to have a little bit more control. Like I want to know how this scales. I want to run my functions forever. I never want to care about cold starts. I want my containers to be like always hot. Like the Premier tier is good for you. And so that's super brand new. It just came out like a couple weeks ago. And finally, the serverless ecosystem on Azure is really 3 parts. So it's Azure Functions, it's Logic Apps, and it's Event Grid. And Logic Apps is, if you're comparing AWS and Azure, Logic Apps is closest to Step Functions, but it's more like, I call it like Scratch for adults. It has about 300 API connectors out of the box, and you just sort of drag and drop and add parameters. And so you can, if you're creating like a bot or something really simple, it's kind of easier to start with Logic Apps and then maybe include functions and other services in with that. And then Event Grid, which is great for sort of organizing all these events. And the closest thing in other platforms is more like IoT. So like AWS IoT and on Google PubSub are kind of the closest to Event Grid. But essentially, it takes in events and then it fires events and helps to sort of organize this event-driven architecture. Okay, moving on to IBM. And IBM is sort of, I think IBM Cloud is sort of lagging behind the other 3 a little bit, but it's more of like a niche cloud. And one of the really interesting things about Cloud Functions and sort of the cloud in general is that it's extremely open. And this is a real concern for companies that have licensing restrictions and they can't use something like Lambda or Azure Functions where there's a black box in there. Like they really need everything to be open and they need to know like what they're deploying to and how things are created. And so IBM Cloud Functions is backed by OpenWhisk, and it's in the Apache Foundation. And IBM employs lots of people to do nothing but work on OpenWhisk. But it's really, really interesting. It's totally open source. You can build it and run it on-prem. You can run it on your machine. You can really run it in Amazon Cloud. Like you can really, I mean, IBM Cloud Functions is the managed version of this that runs in IBM, but OpenWhisk is the technology behind it. I definitely suggest looking at it if you're not familiar because it is really interesting. I mean, I think that I've seen like a lot of talks and everything about it, and companies like Adobe are really bought into to OpenWhisk, but it has a lot of features where things like Knative, which I'm going to talk about in a second, that are coming out on Google Cloud. OpenWhisk was kind of already doing that, but they have a bit of a marketing problem. Like a lot of people haven't heard of them unless they come to a conference and they hear a talk like this, or they're on Twitter and they see something from an evangelist. They have runtimes for PHP and Swift that are official runtimes, which the other clouds don't have. So that's, like I said, it's a bit of a niche thing. I mean, if you're doing mobile development and you want to write backend Swift with a serverless backend, then that's kind of interesting. I think I already touched on everything else, but yeah, the licensing is an issue, and so that's where this solves kind of that problem. Also, if you're working on this, you need help with it. Everyone who works on these tools are really great. I've reached out to lots of people cold and just said, hey, this thing isn't working, and then they've kind of helped me through it, or they pointed me to some open source project. I don't get that. I mean, I get that now with Microsoft because it's my coworkers and I can bother them anytime, but it's hard to get that with big clouds. I mean, it's really hard to call AWS and say, hey, I'm working on a cool little, like, find my cat bot. Can you help me? No, I don't have time for that. All right, so Google Cloud Functions. So this one is interesting, and it just became very interesting after Next. I was watching some of the videos from Next, and I was like, man, I'm going to have to change my talk, and I'm not really sure how to talk about this right now. So Google Cloud Functions was around for about a year. It was constantly changing. It was in beta for Node.js, and it's like alpha, I think, for Python. And it's really cool. I mean, it has a great developer tools, and it's really easy to use within the console. But I couldn't help but feel like it was a second-class citizen kind of to other services, because I would still hear people say, we've always been serverless with app service. And I'm like, okay, App Engine. And so I'm like, okay, what about Cloud Functions? And I kind of feel like it's still kind of like that, because when I was at Serverless Conf in the fall, everyone was talking about serverless containers, which seemed really exciting because it was this idea of like rolling your own runtime for Cloud Functions. And since they have such a lack of runtimes and it's only just now in GA, that seemed really exciting. But then Google Next happened now a week ago, 2 weeks ago, and now it's like, okay, now we have cloud.run, which is serverless containers built on Knative, which is a whole other serverless thing with containers. So I think obviously like Google Cloud is all in on Kubernetes, and they should be, and they're probably running Kubernetes better than anyone because, it's theirs. But yeah, I don't know. They're not totally bought into serverless as to my idea of serverless. They're not bought in as far as the Lambda pattern, I guess. So I don't know. This one's sort of like watch this space, because it's definitely worth building things on Google Cloud, like their data services, their AI. It's really, really interesting. And I'm interested to see like what they're trying to do and where they're going. But right now it's kind of a little bit in flux. So I'm not building anything production on Google Cloud, but it's definitely worth playing around with. Okay, so yeah, quick, like sort of not so quick run through of functions as a service, but go up a couple layers now to serverless architecture, and kind of talk about how back to the event-driven architecture, back to all these other services that are now can generate events that can trigger functions. And it depends on the cloud platform as to what things trigger events. And like I said, we have Azure has like Logic Apps and Event Grid, and AWS has a whole other set of services. I think AWS has the most events generated from services to trigger Lambdas, but there's a lot of with queues, with like API gateways, it's API management on Azure. There's a lot to work with there. I kind of think of these as like Lego blocks, and this idea that we're not like the coders of the past. We're now the engineers of the future, and we just take blocks and build things like Legos. And so we're not spending all day long rewriting every services. We're using things that exist and that are managed and created by the cloud platforms, and we kind of hook them together. And so we get to like go back to being architects again, and to think about engineering and not to think about how many lines of code we write. So these are all parts of our new toolkit. And so we talk about microservices a lot, especially when we're talking about something like Kubernetes. But all functions as a service products are just naturally microservices, and they are themselves containers or execution environments. And so all the benefits that you get out of creating a microservices environment, these are like these little pieces that then help you form that architecture. So one function, I don't think I made that up, but like I've been using it a lot, and so now I'm just sort of taking it over. But each one of your Lambdas, Azure functions, whatever, like should do just one thing, and they should be very, very small so they stay really performant. And they stay lightweight and fast. And then you start getting these other benefits of microservices. You can deploy them independently. They all work together as part of a bigger application, but each piece is its own thing. And really, you can have different developers working on each one, or multiple developers. They can all be different languages if you want. You can have an entirely Java system. You can have a Java system with some Node. You can kind of do what you want, and it's really flexible. So this is my favorite slide. But yes, it's you can create very decoupled systems, obviously with a microservices architecture and functions as a service. And so now, like, I'm really far into the love story now, so I'm really hoping that people are, they're feeling a little love. Yeah. Maybe not. Okay, but yeah, I'm kind of like, sort of summarizing here, just kind of all the benefits of having a dedicated cloud platform and having these services that are fully managed running on this platform. These are, I'm making some analogies here, but speaks many languages. Pretty much any language you write, you can create a serverless architecture now. It was pretty limited to Node and Python or Java in the beginning, but now with like creating your own runtimes and any cloud, any platform, you can go multi-language, you can go any language, and you can scale things up pretty quickly. You can create things, you can deploy them. Your time to production is very, very, very fast. But, as developers, we have some commitment phobia, and we don't like to commit to anything. We don't want to commit to a JavaScript library. It could be uncool tomorrow. We don't want to commit to a cloud platform. We don't want to commit to an editor or anything. And so and first of all, I don't think that commitment is a terrible thing, especially when it comes to cloud platforms. I now want everyone to commit to Azure, but if you commit to Amazon, like, you're not hurting. It's not a terrible place to be. Google isn't a terrible place to be. IBM isn't a terrible place to be. Like, these are all like really great systems, and if you decide to go all in on any one of them, you're in great shape. But we like to stay flexible. We like to be like Taylor. And And so one thing to mention is that a lot of the cloud platforms have really analogous services. So there, if I did like a matrix and I looked at like what's similar in each one, there's something that lines up in most categories. There's some really special snowflakes in different platforms, but they're pretty similar. So if you know one, it's not terrible to move to another one. It's kind of hard to move all of your code from Lambdas to like, let's say, Azure Functions. But I'm going to get to that in a second. Like kind of using some tools and frameworks helps that. I've got two of my favorites that I use a lot here, which is Serverless Framework and VS Code. I already mentioned that I love VS Code. VS Code has tons of extensions. It's not just for Azure. And in fact, it's very intentional to keep it very, very open to be able to use with any platform. So you can use it with AWS. And then Serverless Framework, there are lots of great serverless frameworks out there. Brian's going to be talking about Architect tomorrow. There's Apex, which is TJ Holloway-Chuck's project, but those are AWS. And so since this talk is a little bit more cross-platform, I like to talk about Serverless Framework a little bit because it's cross-platform with plugins. So it's an open source framework. It's written in Node.js, so you have to use Node to install it. If you hate Node, if you hate JavaScript, that part's really fast. You could just install it really quick and then use some other language. Just, spray some hand sanitizer or something and then just start writing Python immediately. But it abstracts a lot of stuff out. Creating an API gateway from scratch, in the portal, can be really, really painful. And when you're using Serverless Framework, you're just putting things in a YAML file, and then it does a lot of things behind the scenes for you, including setting up, CloudWatch or App Insights or whatever that you want. There's a multi-provider plugin system, and people from each cloud platform contribute to that. There's one for Azure. There's one for OpenWhisk. There's one for other frameworks I'm not really talking about, like Kubeless and those sorts of things, so that you can have a more abstracted Kubernetes cluster. And everything's kind of scaffolded with this little CLI. And so this is what it looks like. Once you install it, you create your service. And then you go in there, you change your functions or however you want to. You can set up your development project however you do normally. And then you just deploy. And what you get is kind of what I have here in the bottom. I've got a cat name service and a dog name service to kind of show that you could have a mono repo with different services. And they could actually be different cloud platforms. Cat could be AWS, dog could be Azure. And you could just sort of CD into each folder and deploy them all, and they would deploy to different clouds. That's not really necessarily realistic, but it's something that you can do. And this is just a typical function handler. If I was going to go in and edit this and before I deployed it, I'm just something super small. And really quickly, I want to talk about this. So when I gave this talk before, and when I've talked about this idea of not committing to a cloud platform or using multiple cloud platforms, or using tools, there's always this sort of thing of, okay, but each cloud platform generates their own type of event that has its own format, and what do I do about that? And so I just wanted to briefly mention, to go a little deeper for a second and briefly mention cloud events. So this is something that the Cloud Native Computing Foundation is working on, which is this standardization of events that are fired from services within the cloud platforms so that you can more easily go multi-cloud. And last year at KubeCon Europe, Kelsey Hightower and Austin Collins both did separate demos where they wrote bots and they were firing events between all different cloud platforms. And it was really, really interesting, and it kind of gave you this idea of how you might do multi-cloud with events firing, rather than having completely different applications hosted on different clouds so you can diversify. It's this idea that they could all talk together, and that's this huge event-driven system. So Azure Event Grid allows you to already use the current schema right now, but it's still in flux. It's still in beta. This is sort of like the future, and it's just something to like kind of think about to keep your mind open. I don't know what AWS is sort of doing in this realm or Google, but Serverless Framework also has like a hosted event gateway, which they used for their demos, and that's kind of still in development as well. But anyway, this is the idea for sort of open cloud that's coming in the future. Demo time. So I'm not going to live deploy. If you want to see me live deploy, like I have some videos where I've done it, but today I wasn't trusting the internet, and so anyway, I deployed last night instead. But this is the audience participation part. So if you're on Twitter, you just have to mention these cats tweet, at these cats tweet, and use the hashtag ValentineBot. You can also just sit here and look at this GIF too, because this is so creepy. I just love how creepy it is. So just send a tweet, any kind of tweet, and I have a serverless bot that's running that I deployed to Azure, and I've got it in here. Also, this is super small, but. So this is my GitHub, Linaloo. I push lots and lots of stuff up there. I have no regrets. I just YOLO push to GitHub all the time. Valentine's Day bot is up there. I've got different folders for AWS and Azure. This is using Serverless Framework. I just kind of copy pasted from AWS to Azure. This isn't super clever at the moment because it's just sort of a side project I play around with. But I deploy to either, just depending on like what I'm talking about or what I want to do. Let me go back to my slides in case anybody's tweeting. Anybody tweeting? All right, and I will go to Twitter. These cats tweet is like my bot accounts. There's all kinds of weird stuff in there. It just depends on what I'm talking about. This is the new Twitter interface too. All right, cool. Somebody has tweeted, and so it should respond to you. Oh, there's more of them coming in. Even a GIF. Sorry, showing your work in front of the class, everyone. I didn't even ask for your permission. Here you are. Here's your face on the screen. It's recorded. Sorry. You can see, too, from when I gave this talk before, somebody was like, what's going on here? Just some random person following the hashtag, like, what? All right, and so this is my bot responding back to people here. So basically what it does, it's a pretty simple bot. I'll go back to my slides for a second, and then we'll go back to that. Here's the GitHub. But basically it's just using the Twitter API for Node.js. It is JavaScript. Apologies to everyone who hates JavaScript. You don't have to write it, just look at it, just briefly. It's using a scheduler service. That could be Timer on Azure, it could be CloudWatch events on AWS. And it's pulling all of these GIF images from storage. It's using the FAST service. The FAST service just basically does some polling to Twitter to find all of the tweets, and then it sends a response to you. And I'm using Serverless Framework and VS Code. This is going to be super tiny, but anyway, here's VS Code, and I have just this little responses.js where I just put all the responses in here. Like I put a couple like Philly ETE ones in here before I deployed, so it just pulls them randomly. So depending on how lucky you are, maybe you get like a Philly ETE inspired one. Let's look back again and see who got responses. Couple people did not get a GIF, so maybe there's some bad GIF in there or something. I'll look at my logs later. Yay, thanks everybody for all the participation. That's awesome. Anybody? Sometimes people send me pictures of their pets. I'm not seeing that, but people are all saying hello to the bot. Nothing bad in here. I'm just showing it. So if you put something really mean in there and it's not lovable, I'm going to call you out. Be on here. Cool. There's some more. This is a pretty good one. I just like looking at all my gift choices. So one more thing I wanted to mention was Logic Apps. This is just one more thing to mention on Azure, because I just think this is really cool, and this is something that people don't necessarily know about if they're used to AWS. But this isn't a screenshot from my Logic app, but in my code that I just wrote here for this bot, I just used all functions. But if I wanted to use Logic Apps, there is a Twitter connector. So if somebody doesn't even know how to code and they just want to create a Twitter bot, they can actually use Logic Apps, bring in the Twitter block, do their auth, like do some params, and then have that call a function. So the function that I use to reply to tweets, my Logic app could then call that. And like I said, there's 300 connectors. There's like some pretty cool stuff you can do there. It's kind of like no code, low code, which is interesting if you have people that have requirements for things and they don't necessarily want to write code. They just want to do, Scratch for adults. So I just want to mention that, because if I was creating this from scratch in Azure, I'd probably use that for at least part of it. Here's some more people getting famous. Oh, wait, is there a dog? I think I saw a dog. Yes. That is an awesome dog. He's doing some hunting. There's like somebody mowing the lawn on the other side of the fence, and he's like guarding now. Oh, and this is good. Ron, how many dogs do you have? Where's Ron? Tell me more about these dogs. Forget the Q&A, Ron. Like, let's introduce these dogs. All right, cool. Awesome. All right, so the requirement for Q&A is you have to start every question with, I'm gonna let you finish. Thanks for getting that joke. I had to include Clippy in here too. Okay. So, all right. So I think these are my questions. I'll read them out, even though I'm sort of putting this up a little bit. And I have about, 5 minutes if I want to run the clock. If I don't want to answer somebody's question, then I'll just go on a soapbox about something else again. Okay. Cron jobs and timers require a stateful environment. How would you solve that with a serverless architecture? Yeah, I would use I'd use the managed services. I don't know if that really answers the question, but in Azure, timer is a service, and it's I don't think I've ever paid for timer. And same thing with CloudWatch events. If I have these types of bots, I've never gotten a bill for this bot, or I have an Adopt-a-Cat bot that tweets SPCA cats every hour, and I've never paid for a CloudWatch event. So maybe this falls under the category of I don't care. If it doesn't cost me any money and it's really performant, then good to go. But yeah, something stateful can still trigger a Lambda, and I still consider it part of the serverless architecture because it's still event-driven. I want to get started in Lambda. Well, first you should just use Azure Functions if you're getting started. Yeah, I'd use Serverless Framework. That's where I would start, because I think it's easier, because I think that you can get lost in the console of any cloud provider, and I think Serverless Framework just feels more developer-y, I think, because you're in the command line. So I would use Framework. And then once you use that, then you might say, okay, I really want to understand what it's doing, and then you can go log into your cloud provider and kind of poke around and understand it. And from that point on, you might say, okay, I really think I'd rather use AWS SAM, I'd rather use VS Code with Azure extensions, whatever, but I'd start with a framework. Login and auth handled in Lambda. For like web apps, you'd use like Cognito if you're building a web app, or you can use Auth0, or there's lots of different like third-party providers that you can use if you want people to access the web from the outside. I'm just trying to answer these pretty quickly so I can get through more of them. Are there service mesh tools like Istio if I'm coding in a serverless model? I don't know. I mean, I think for something like Istio, I mean, I think you can use like API management or API gateway to do the same thing, but honestly, I don't know. I'm not that familiar with Istio, so I don't know everything that it does. So I don't think I can answer that. But I can like kind of look it up and give you my opinion later. How difficult has it been for you to get teams to change from creating extremely chatty applications, hundreds of gets to load a page, to a chunkier, more case-driven approach? So it's been, for teams, for development teams, it's been very easy because this is cool and this is fun, and a lot of developers are really interested in the cloud and they don't know where to start. It's harder for managers, because managers are like, whoa, we don't know about this serverless thing. Like, what about our servers, you know? Or like the security people or the infrastructure people, because maybe they feel a little bit like, I really like setting all this stuff up and I don't really trust Amazon to manage my things. That's another soapbox thing for me, is like being afraid of the cloud knowing about you. I can talk about that in great length, maybe over cocktails. But yeah, development teams I feel like is pretty easy, especially because you can bring your own language, right? Like before serverless and before containers, like the idea of modernization was you have to change your language. Oh, you're using COBOL, you got to go to Java. Oh, you're using Java, we hate Java, you got to use Node. Oh, you're using Node, Node is terrible, we got to use Go, Rust, whatever, right? Now it's like, no, it turns out your language is great because you like to write it and you're really good at writing it, so keep writing it. And just change where it's hosted, change your architecture, like use some services that are already written, don't reinvent the wheel. But like, yeah, if you like it, use it. Use cases where serverless won't be the right solution. Government, certainly. Like I don't even know, like GovCloud doesn't have a lot of the services. Like long-running services, you're still going to want to use containers. Maybe you still have a serverless architecture, though, because you can still use your Lambdas, your Azure functions for like some of your cron jobs and like some of these like smaller little chunks. But yeah, there's definitely places where I wouldn't recommend it. I think that I like to start there, and then if it's not feasible, if it doesn't make sense, move on to something else. But in a lot of places where cloud development in general is a struggle, then that's where serverless is going to be a struggle too. I've got less than a minute. What's the best way to decompose an existing microservice-based backend into a purely functional serverless architecture? Very gradually. I have another talk that I have given about gently breaking apart your monolith. Like don't tear everything down and like start from scratch. Or, you know, I mean, I guess, or start from scratch with little pieces of your app, but there's always these little pieces of your monolith or your other application, your microservices architecture that are like easy. Like they're your low-hanging fruit that you can pick pretty easily from the tree and just like create a little service. And there's something to be said about getting to production really quickly. It just makes you feel better. I mean, if you're struggling with infrastructure, if you're struggling with frameworks, if you're just struggling to get past something, you're going to feel terrible. You're going to give up. It's not any fun. The faster you get to market, the better you feel. And also the more ROI. I mean, the more like, oh, hey, look, we already have something in production. Like we have this giant monolith. We know we need to break this thing down, but we already took our API layer and we've got that running in serverless. Like, that's pretty cool. Like, your boss is going to be happy. They're going to be like, good job, team. You guys learned AWS really quickly. Now go get that cert, you know? Which one is more cost-effective, Lambda or Azure functions for large enterprises? They're the same. I think they're the same. I'm supposed to say that Azure's cheaper, but I think they're the same. Yeah, it just depends. I mean, Azure's not trying to be cheaper than Amazon. Amazon's not trying to be cheaper than anyone else. Cost is like, I think, the thing they care about the least. They've got their own sort of agendas. And they want people to adopt, and they want people to spend money, but yeah, one's not cheaper than the other, I don't think. All right, I think I am out of time. It is 2:31. All right. Thanks, everybody.